going to start off with some definitions. And these are going to be reviews of definitions from grade 11 pre-calculus to see if you remember some things about angles and trigonometry. First is, or the first definition that we're going to look at is what it means for an angle to be in standard position. So what I'm going to do first, before we write the definition, is I'm going to give you examples of angles in standard position and ones that are not. I'll draw a line right here. These ones are yes, these ones are no. So if I have my 4 quadrants, this would be an example of an angle in standard position. This would be an example of an angle in standard position. So with this, so with this. All 4 of those are examples of angles in standard position. These are examples of angles not in standard position. So I want you to look at the pictures of the ones that are yes and the pictures of the ones that are no. And from those pictures, see if we can come up with the definition. What does it mean for an angle to be in standard position? See if this makes sense. Notice that if I draw the positive x-axis on each of the ones that was a yes, that's where the angle starts. It can go clockwise or counterclockwise. We will find out that angles that go counterclockwise are positive angles. So this would be a positive angle. This one in clockwise direction will be a negative angle. So we have positive angles and we have negative angles. But all of these other ones are not angles in standard position, because if we look where the angle started, there, there, notice that where those angles started was not the positive x-axis. So mathematicians like things to be standardized so that if they're communicating with each other and they say, oh, we have an angle of 40 degrees in standard position, then somebody else can go, oh, I know exactly what you mean and I can draw it. And this is important for not only mathematics, but for all areas of industry. You want somebody to know what you're talking about, right? So if you're working for a car factory and say, I need a wheel, right? It needs to have a certain size, right? Because you're like, oh, this car has a flat. Can you send us a wheel? They'd be like, oh, great. Here's a big tractor wheel. You're like, that doesn't fit. We need some sort of measurement or some sort of way of standardizing things so that we can communicate better. So that's definition number 1. Definition number 2 from grade 11. Different than an angle in standard position is a reference angle. again, I will draw, let's put the line up here. I find seeing the definition a lot better than the words. If you write the words, sometimes you don't understand it. Seeing the visual really helps you understand it. So these are reference angles. And these are not reference angles. So take a look at those pictures. And the definition of a reference angle is the angle between the terminal arm and the nearest x-axis. So what I'm going to do on all of the S1s is I'm going to draw the terminal arms. A terminal arm is where an angle ends. Terminal means end, so the terminal arm is where the angle ends. This is where each of the angles end. For all of the ones that were yes, the angle that was labeled was the angle between that terminal arm and the nearest x-axis. Not the nearest axis, right? Because I have that in the bad ones here. We have our terminal arms, again. Here's our terminal arms in purple. Whoops, that one's wrong. There's the terminal arm. There's our terminal arms. Did we find the angle between the nearest x-axis? No, because if I draw my nearest x-axis, it should have gone to here. In this one, it should have gone between here. This would be the nearest x-axis for this one, and this would have been the nearest x-axis for that. Reference angles are extremely important for trigonometry because when you started trigonometry in grade 10, you just did triangles, which kind of makes sense. Trigonometry is about triangles. And your triangles, when you draw them, in fact, the triangles that you used were all right-angled triangles. Do you remember SOHCAHTOA and a squared plus b squared equals c squared? That only works with right-angled triangles. And when you have a right-angled triangle, your angles are always small, right? I can't have any angle bigger than, this one's 90. I can't have angles bigger than 90 degrees in here because a triangle's angles add up to 180 degrees. And that was grade 10 trigonometry. SOHCAHTOA and a squared plus b squared equals c squared. In grade 11, you were introduced to reference angles because what happens is sometimes you have an angle in standard position, say here's my positive x-axis. I'm going to go over here. Let's say this angle is 150 degrees. If we have that angle of 150 degrees, we would say that our reference angle right here is equal to 30 degrees. And notation that we used, we often use theta for angles. We put a little tiny subscript r for the reference angle. So the reference angle for 150 degrees would be 30 degrees because here's my terminal arm. What is the angle between it and the nearest x-axis would be 30 degrees. Now an interesting thing happens is if you go to your calculator and you do sine of 150 degrees, your calculator gives you an answer. Your calculator will give you an answer of 1/2. But you can't draw a right angled triangle with a 150 degree angle. It's impossible. So how do we get that sine of 150 degrees? Because you learned in grade 10 that the definition of sine was the opposite side over the hypotenuse on a right angled triangle. That's what sine means. But if I have 150 degrees, I cannot draw a right angled triangle. However, with 150 degrees, if I use my reference angle and I choose any point on my terminal arm and I go down, I can make a right angled triangle there. And if I make a right angled triangle there and I measure the sides, so I take out my ruler, I measure this side, let's say for simplicity this is 1, I measure this side, it happens to be 2, so then sine of 30 degrees is also 1/2. So our reference angles help us figure out sine, cos, and tangent of bigger angles, still related to a right angled triangle. And what it means is that if you have 150 degrees, you could find its reference angle, draw a triangle with the reference angle, and then be able to calculate, oh, I know that sine of 30 degrees is 1/2, so I know that sine of 150 degrees is also 1/2. And another thing that you learned in grade 11 was the CAST rule. The CAST rule is just an acronym to help you remember where things are positive. The A stands for all of them are positive. That's sine of 30 degrees, cos of 30 degrees, tan of 30 degrees. Type them all into your calculator. They will all give you positive values. But the S in quadrant 2 says only sine is positive. And if you would type cos of 150 degrees into your calculator and push enter, your calculator will tell you negative 0.866. It will give you a negative value for it instead of a positive value. And same thing, T says only tangent is positive, and C says only cosine is positive. So what that allows us to do is, if I want to find sine of, here, since we already know sine of 150 is 1/2, if I want to say I'm drawing 330 degrees, this would still have a reference angle here back to the nearest x-axis of 30 degrees. And if I go to my calculator and I type in sine of 330 degrees, I will also get 1/2, but this time I will get negative 1/2 because it's in quadrant 4. Because if I make a triangle here, I could choose any point on there. If I choose where this length is 1, can you see that this will be the identical triangle to this other one in quadrant 2, just sort of flipped and put in a different spot. The angles are all the same. And if I chose a point where the side length was 1, the sides would all be the same. Those triangles would be identical. So that's the reason why sine of 150 and sine of 330 give you the same value on your calculator. But we need to have a way to determine where things are, and we find out that according to the CAST rule, some places things are positive, some places things are negative. Grade 12 trigonometry will help explain why that happens. So maybe in grade 11 you were just told, this is your cast rule, you have to know that only sine is positive in quadrant 2. In grade 12, there will be an explanation for that using what we call the unit circle. And we're going to get to that today. Okay? A third definition, this one might be new, not from grade 11. Coterminal angles angles that share the same terminal arm are called coterminal angles. So what we can do is we could say that 40 degrees ends in the same place as if I went all the way around. If I went all the way around, that would be 360 degrees, plus another 40 would be 400 degrees. We could say that both 40 degrees and 400 degrees are coterminal because they end at the same spot. And that too, we're going to find out that if you go to your calculator and you type in sine of 40 degrees, and then you type in sine of 400 degrees, you will get the exact same answer. Because if we drew their reference angle, and with either one made a triangle back to the x-axis, you would make the same triangle. They both share the same terminal arm, you're going to make the same triangle back to the nearest x-axis if you chose 400 degrees or if you chose 40 degrees. So we call angles that end in the same place coterminal angles. All right, there's our definitions for introduction. We are now